Hey folks, it's Jimmy here, burning the candle at both ends to bring you this. I picked up a stainless steel measuring cup at Meijer today. You may have guessed I'm from the Midwest because we have Meijers all around here. Maybe you have a Piggly Wiggly's or a Stop and Shop. But here in the Midwest, we shop at Meijers. I picked up the stainless steel measuring cup so that I could melt the gallium, the indium, and the tin into Galistan. You may recall from an earlier video that I ordered this LTKJ 4-piece torch melting kit, but it didn't arrive in time. Hey, it's no big deal, if you want to send me this thing like 2 or 3 months later from when I ordered it. I'm just trying to help save the earth. That's all. So I'm not used to the scientific method, and I just want to gather some facts to start off with. So take a look at this little measuring cup that I picked up at Meijer's. It weighs about 3 ounces. Now, I also just plugged in this new carbon measuring device. I have realized that I need to click on the settings menu and then scroll to the second page and then click the reset button and then click the little start button that kicks off the reset so that it recalibrates itself. Then I take a look at the carbon measurement in parts per million. I also take a look at the room temperature. So you may notice we've got 388 parts per million carbon, and we've got 66.5 degrees for room temperature. That's important because gallium melts at about 85.5 degrees Fahrenheit. And the reason why the measurement keeps getting higher is probably because I'm in the room breathing. In case you didn't know, humans breathe in oxygen and breathe out carbon dioxide. And by the way, so does my cat. Oh, and so does yours. Unless you're a conspiracy theorist and then maybe your cat breathes in nitrogen and breathes out hydrogen. So we're going to start by placing the indium and the tin into the little measuring cup, and then we'll add the gallium later. And I better remove this little rubber handle thing. It's just going to get melted. So I'm just going to do this on the stove in the kitchen. And I know it's a mistake, but I've got to fail fast. I've got to figure out what works and what doesn't work. If the equipment would have shown up on time, then I could have done this on the grill outside. And it's not just that. It's cold outside too. I'm a software engineer and I don't usually work with chemistry. These kinds of constraints are very difficult. But if a way can be found to define the constraints and realize the limits, then the chances of success can continue to increase. There's always a lot of honesty that's required to be successful when you're working through a project. You can't lie to yourself and say, hey, I got this, when you don't. You have to be able to say, I'm going to fail at this, and that's okay. And then respectfully observe, make judgments, make a new plan, and then move on and execute again and again, iteratively, until you succeed. And speaking of success, it looks like the indium and the tin have melted at a very low temperature, which is kind of surprising because I think I read that the melting point of tin is 300 degrees Fahrenheit. On the other hand, you can't really trust anything you read on the internet. Unless it's a conspiracy theory, then you know it's probably true. So the gallium comes in a little plastic container, and I tried to warm it up with my hands, but it didn't melt. So I'm just going to put it in this hot water, and this is actually tap water. I didn't even heat up the stove. So now I'm going to add the Galistan to the indium and the tin to create a compound of eutectic metals that's called Galistan. I think that someone named Stan must have named it, because it doesn't make any sense. It seems like it should be named Gallon Tin, right? But anyway, it is working. And that's super important because out of all the videos that I've made so far, it's been very convoluted and based on gathering data. So at least there's some progress here. And I think at the very least that this video is a really good reference for how to create Galistan, even though I hope there's going to be a lot more to come from this. And we're going to be able to actually sequester carbon from the atmosphere using liquid metals. And it looks like we've got about 2.6 ounces of Galistan when you subtract the weight of the stainless steel cup. However, the eutectic metals don't seem to want to stay in a liquid state at 66 degrees Fahrenheit. In the summertime, it'll probably be more like, 70 or 80 degrees around here, 90 degrees, whatever. So it may be a little easier then, but I need to find a better way to keep more controls around these experiments. Her daddy met her once, he had to leave. Never wore silver bells, no privilege it seems. Never saw the ocean till she was 17. Jobs she didn't know. In and out the window that girl comes and goes. A path along the river and the winding stream. Underneath the railroad bridge she lost her belief. Curses, words of dread, so many kind words out there left unsaid. She jumped into his car with just her shirt and jeans. No one to believe in, so she followed her dream. Street lights in the background. Daddy met her once, he had to leave. Never wore silver bells, no privilege it seemed. Never saw the ocean till she was 17. Never saw the ocean till she was 17. Never saw the ocean till she was 17.